Hey, what's up, everybody? I just wanted to give you guys a problem that came to me today. I answered the problem, but I didn't answer it as thoroughly as I should have. So here it is. Take a look. So we have a function, let f of x equal 3x squared, and suppose we want to approximate the integral from 0 to 2 f of x dx by using a left rectangle approximation method. All right, write but do not evaluate the Riemann sum, I mixed up the I and E there, which approximates the integral from 0 to 2 f of x dx with 10 rectangles. All right, so I went ahead and printed a graph, and so we need to have 10 rectangles here. The first thing we're going to do is cut this into 5 sections, or I'm sorry, 10 sections, right? So 1/5, 2/5, 3/5, 4/5. Good Lord. Let me back up just a step. The left rectangle approximation method. So this is going to be very rough. I probably will not be able to get all 10 rectangles in here, but I wanted to give you an idea of the Riemann sum that we are trying to represent. All right. Now, actually finding the left Riemann sum, or finding the left rectangle approximation method is probably not the trouble. The trouble comes when we are actually writing it as a Riemann sum. So I was unable to get all 10 rectangles in. 4, 5, 6, 7. I didn't do too bad. I got 7 of them in. But this is about what it looks like. So what we need to do is just get some kind of process down to where and we have to memorize a couple of formulas. Okay, so we need to know that the integral from a to b of f of x dx is the same thing as the Riemann sum, so it's a summation, okay, of f of x sub I times delta x. And typically I represents the number of rectangles, all right, or the number on the rectangle. Okay, so if we're doing a left Riemann sum, the first rectangle is actually going to be numbered 0. Typically, though, we do right Riemann sums so that we can just go from 1 to 10. But if we number the first rectangle 0, then that would be rectangle 0, rectangle 1, rectangle 2, and so forth, all the way up until we get to rectangle 9. So the counting variable is going to be from 0 to 9 in this case. I guess I should have written the formula. So instead of saying from 0 to 9, so instead of saying from 0 to 9, I should be saying from 0 to, let's say, some value k, the number of rectangles. So if I were to write the integral, in this case, it's the integral from 0 to 2 of 3x squared dx. So then I'm going to turn that into a Riemann sum. So Riemann sum, or summation symbol, I equals 0 up to 9. And now I have to find f of x sub I. Well, what is x sub I? X sub I is typically, well, the formula for it is a plus delta x. Actually, let's put an I in front of that. A plus I delta x. A is 0, B is 2, and the n value we already said is 10 rectangles. So 0 plus I, we said delta x. Let's find delta x. Delta x is b minus a over n. That's just another formula we have. So 2 minus 0 over 10, and that is 1/5. So 0 plus I, delta x is just 1/5. So in other words, x sub I is 1/5 I. Okay, so this is, I need the function evaluated at 1 over 5I. And then we need to find delta x. Well, delta x we just found, so that would be times 1 over 5. And with a little bit of manipulation, all I need to do now is substitute in, let me get my red pen, I need to substitute in that in for x. So that becomes summation symbol, I equals 0 to 9. The function is 3x squared, so it's just 3 times 1/5 I squared times 1/5. And then finally, a little bit sloppy here, but bear with me, it is I equals 0 up to 9. 1/5 squared is 1/25. 1/25 times 1/5 is 1 over 125. So this is 3 over 125 I squared. And I think the answer key, the multiple choice that this person was given, it looked like this: I equals 0 to 9, 0.024 I squared. And that's the one we eventually guessed, but I was I got to a point where I was I don't know, I'm stumped. So anyway, we finally got to the solution, and thanks to the person who brought that question to me, and I hope this helps somebody out there. All right, see ya.